All right, so let's move on. All right. So in case you forgot, if you remember the formula for the central limit theorem, we just say if n is greater than or equal to 30, we could say our data set is normally distributed. So that still follows the same thing for the t-distribution. We could still apply the central limit theorem for a t-distribution as long as our sample size is big enough. So if our sample size is greater than or equal to 30, we could still apply the central limit theorem. And in case you forgot, why do we apply the central limit theorem? We apply the central limit theorem when we don't know if our distribution is normally distributed. So let's go down. All right, so this is gonna be our first problem. So when you read these problems, you kind of want to read it as a sentence. So that's one sentence. Here's another sentence. So far. So if you look at it, we got two different sentences. So for the first sentence, it says, assume the resting metabolic rate RMR of a healthy male in complete silent is 5,710 kJ per day. So then it said, researcher measured the RMR of 45 healthy males who were listening to calm classical music and found their mean RMR to be 5,708.07 with a standard deviation of 992.05. Right. So lastly, it's saying at the alpha equal to 0.05 level of significance, is there evidence to conclude that the mean RMR of a male listening to calm classical music is different than 5,710 kJ per day? All right. So right now we're gonna focus on the sentence that I highlighted in red. So what was the 45? What did the 45 represent? Cool, sample. Perfect. So we get, oops. So if we get a sample of 45. All right. Everybody good on n is equal to 45. All right. What about the 5,708.07? What does that represent? Okay. All right. So I got X bar, I got S, I got mean and mu. All right. So if you do read the problem, it says the mean. So it says mean, and this is the mean. So then what you have to do, you have to be able to figure out if it's the mean of a sample or if it's the mean of the population. So that's where it's important that you read the sentence. So if you look at that sentence, the sentence gave us a sample. So they told us we have a sample of 45 and we found the mean of that sample to be 5,708. So this is our sample mean. So that means all of the information they give me in this sentence, all of it gonna be sample. So if you look at it, they also gave me standard deviation in this sentence. So since they gave me standard deviation in this sentence, that means this standard deviation is coming from the sample of 45. So that means this is S. All right. Everybody good so far. N is equal to 45, X bar is equal to 5,708.07, and S is equal to 992.05. Cool. All right. What is my alpha equal to? 0.05. All right. Lastly, what's supposed to be the metabolic rate for a healthy male? So if a male is healthy, what should be their metabolic rate? So what should be their mu? Yeah, good. 5,710. All right. So that's all. Sorry, that's all of the information we got. Everybody good so far with all the information we have notated? All right. And if you want, you could talk. Like I could hear everybody. So if it's easier for you to shout out the answer, just shout out the answer. All right. So right now, what we want to do is state the null, and we want to state the alternate hypothesis. So for the null hypothesis and the alternate hypothesis, what we're trying to figure out the claim is. So if you look at it, we already got mu is equal to 5,710. So that's going to be our null hypothesis that mu is equal to 5,710. And we put mu 5,710. So what we're trying to decide, we're going to try to figure out which symbol should I put in between here. So we want to pretty much be able to figure out if I should use greater than, less than, or not equal to. So if you want to put greater than, type in A on the chat. If you want to put less than, type in B. If you want to put not equal to, type in C onto the chat. All right, so we got 1 for C, 3 for C, perfect. So what's the keyword that kind of tell me that we should put not equal to? Yeah, perfect. Different than. Oops. So different than is the key word. So they don't care if it's greater than 5,710 or less than 5,710. We care is it different. So that's why we're gonna put not equal to. All right. Any question on how we stated the null and the alternate hypothesis? Right. All right, so right now what we're gonna go ahead and do, we're gonna go ahead and shift over into Class Calc. So if you have Class Calc, this is the time that you should be using Class Calc. All right, so okay. So for Class Calc, what we want to do, we want to run a test, and we want to run a t-test because this is a t-distribution. So in Class Calc, let me get it up. You want to go to the Stats button, and if you look all the way over here, it says Test. So if you look at giving all of these different type of tests, but the test that I want the t-test. So if you look in the first one, it says z-test. You don't want to do z-test. You want to do a t-test. So if you look at the second row and the second to last option, you should see t-test. Everybody see the t-test? All right. So if you look at it, asks me for mu. Mu we said was 5,700. Oops. 5,710. If you look at ask me for X bar, which is 5,708.07. And if you look at S of X, X of S is standard deviation, so that's 992.05. And lastly, N is 45. All right. Any question on how I did the input onto ClassCalc. All right. So if you look at the first thing it gave me the t value. So it gave me t value. So that's our test statistic. So we're gonna say t is equal to negative 0.01, and we'll put 3. Also, if you look at it, it gave me 3 value. So these are my p-value, but only one of them is correct because you have to look at the inequality that we put for the alternative hypothesis. So if you remember for the alternative hypothesis, we put not equal to. So since we put not equal to, our p-value is actually going to be equal to 0.9896, whatever it is. All right. So our p-value should be 0.9896. Any question on how I got that so far? All right. So before we actually move on to the problem, I'm going to show how to do it if you have a TI-84. So if you have a TI-84, prepare yourself to practice on how to do this test. All right, so for the TI-84, what you want to do, you want to hit the stats button, and then you want to move it over where it says test. And then what you want to do, you want to select where it says T-test. So if they're going to give you the option to choose data or stats, in our case scenario, since they gave us all the information, is actually just stats. So for the mean, you put 5,710. Sample mean is 5,708.07. Sample standard deviation is 992.05. And lastly, n will equal to 45. And then if you look at it, they give you the option of which 3 of these do you want to choose. I'm going to choose the first one. And then you go to calculate. So if you look at it, it gave you the t value, which is equal to negative 0.013. It gave you p, which is 0.9896. Any question on how I got these values using the TI-84? Perfect. All right, so I'm gonna go ahead and just switch back to my notes. All right, so if you look at the notes, I put test statistic is t is equal to negative 0.013. If you look right here, we say p value is 0.9896. All right. Everybody good with those two values so far? All right. So if you look at those two values, well, let's look at the test statistic. The test statistic, it gave me negative 0.013. So they're kind of telling me there's not that much of a difference between the sample mean and the population mean. So they're telling me the population mean and the sample mean are pretty close to each other. And if you actually look at them, they are really relatively close to each other, because if you look at the sample mean, it's 5,708.07. And if you look at the population mean is telling me it's supposed to be 5,710. So if you look at it, there's not that much of a difference. That's why we got a t-value that's such a a t-value that's close to 0. And also, if you look at the p-value is also kind of telling us that there's not that much of a difference. All right. So let's go ahead and let's do the comparison. So we want to compare p-value, and you want to compare this to alpha. So if I go back up, I jotted down that alpha is equal to 0.05. So for this one, which one's bigger, my p-value or alpha? So p-value of 0.9896 or alpha of 0.05? All right. So for this one, if you look at p-value is definitely bigger than alpha. Because if you look at 0.98, that's pretty much 0.98 versus 0.05. So 0.98 is definitely bigger than 0.05. So since p-value is bigger than alpha, which conclusion should I come up with? Should I fail to reject, or should I reject the null hypothesis? So fail to reject HO or reject HO. And you should have some notes on it when we went over the beginning of 10.2. Perfect. So we'll say fail to reject HO. So when we fail to reject HO, you're telling us the difference between our sample mean and our population mean. There's not that much of a difference between the two of them. So that's why you fail to reject HO. Right. So let's go ahead and start with the conclusion. So all right. So for this one, should I put there is enough evidence or should I put there's not enough evidence? So is or not. Well, anytime you fail to reject the null hypothesis, you always want to put there is not enough evidence to support the alternative hypothesis. So for this, you want to put there's not enough evidence to support the alternative hypothesis, and then what you want to do, you want to state what the alternative hypothesis is. So the alternative hypothesis will be that the mean RMR, so let's say the mean RMR of a male listening to classical music is different than, what was it again? 5,710 kJ per day. And that will be it for your conclusion. So for this one, we'll say there's not enough evidence to support the alternative hypothesis that the mean RMR of a male listening to classical music is different than 5,710 kg per day. Well, kj per day, sorry. All right. Any question for that first example? All right. So let's go ahead and do the second example. So let's work on the second problem. So it says a biologist was interested in determining whether sunflower seedling treated with an extract from vinca minor root resulted in a lower average height of sunflower seedling than the standard height of 15.7 centimeter. The biologist treated a random sample of n equal to 33 seedling with a extract and substantially obtain the following heights. All right, so if you look at this one, the standard height of this sunflower is 15.7. So that's our average. So 15.7. But that's pretty much everything else, pretty much everything they gave us. Well, they also gave us n. N is equal to 33. Everybody good for mu and n? All right. So if you look at it, we have our sample. So from this sample, we're gonna be able to find what the sample mean is. We're also gonna be able to find what the sample standard deviation is. So from this sample, we're gonna be able to find the sample mean and our sample standard deviation. One thing also that they didn't give us is alpha. So alpha, anytime alpha is not given to us, we automatically assume alpha is equal to 5% or 0.05. So in this case, we say alpha is 0.05. So this is just a rule of thumb. Anytime alpha is not given to you, just automatically assume alpha is equal to 0.05. So in a test or in a quiz, if I ever don't give you alpha, automatically assume alpha is equal to 0.05. All right. Everybody good so far what I have on the screen? All right, so let's go ahead and do the null hypothesis. And let's do the alternate hypothesis. So if you notice, we already know what mu is. We know mu is equal to 15.7. There you go, 15. Oops, I forgot to put mu. There you go, mu and 15.7. But what we have to do for the alternate hypothesis, we have to figure out what should be the inequality that we put in between the mu and the 15.7. So we could either put that as less than, we could put that as greater than, or we could put that as not equal to. So what are they trying to prove? If I use this extract, what's going to happen with the height of the sunflower seed? Is it going to get bigger than 15.7, smaller than 15.7, or it is just going to be different than 15.7? And if you want, you could, cool, yeah. So it should be lower, because if you look right here, it says result in a lower average height. So it should be lower. So for this one, we're going to say less than. And that's your null, that's your alternate hypothesis. Any question for the null or the alternate hypothesis? All right, so up next, we're going to go ahead and do a test statistic. So I'm first going to do this with ClassCalc, and then I'm going to do it with the TI-84. So if you're doing it with the TI-84, what I want you to do, get a head start and start entering these numbers into your calculator. So enter this into L1. So let's show you how to do it with the ClassCalc. So ClassCalc. So I'm going to go here with this stats. I'm going to go here with this test. And once again, I'm going to choose the t-test. Because if you look at this one, they don't give me the population standard deviation. So that's why we want to use the t-test. If you look at ClassCalc, it gives you two options. It tells you stats or it tells you data. So stats is when I give you everything. So if I give you sample mean, sample standard deviation, and if I give you all of that, you want to choose stats. But if X bar and sample standard deviation is missing, that's when you want to put data. So if you look at it, only want two things. It want the mu, which the mu is 15.7, and then want the data. So this is where I'm going to enter all of the data. So you go 11.5, you put a comma, 11.8, comma again, 15.7, comma again, 16.1, comma again, 14.1, comma again, 10.5, comma again. All right. So that is it. All right. So I enter all of the data set for this. So if you look at it, it gave me a t value. So tell me t is equal to negative 4.5. I'm going to say 9. So if you look at it, we get negative 4.59. So if you look at it, it's kind of telling us we have a big gap between what the mean height should be and what the mean height was after they put this extract onto the sunflower seedling. So it kind of telling us we have a big gap. So it kind of telling us that this is actually working. For the p-value, which of the p-values should I use? Because they gave me 3 p-value, but only one of them should be the p-value that I'm actually using. So what's the p-value that I should be using? Yeah, good. So the one that says less than. So we're going to use p value is equal to 0.0000, and we'll say 4. Okay, if you look at the 7 got to round up that 3 into a 4. All right. Any question on how I got the t value and how we got p value? All right. So up next, what I'm gonna go ahead and do, I'm gonna go ahead and show how to do this with the TI-84 for people using TI-84. So for the TI-84, you go to Stats, you go to Edit, and you enter all of those numbers set in. All right, so what I'm gonna go ahead and do, just enter this data set again. So 11.5, 11.8. Alright. So you enter all of that in, and if you look at it, if you go to the very last number, it should tell you that you have 33. So if you look at where it said L133, it's telling me that we have 33 number set, which is correct. All right, so all you have to do, go to stats, go to test, go to t-test, and then change it from stats to data. And then the only thing I'm gonna ask for you is your mean, so that's 15.7. Everything else pretty much stay the same, except for this one, we wanna choose the less than, and we go over and calculate. All right. So if you look at it, we get exactly the same thing. The only thing that's a little bit different, if you look at the p-value, it gives it to you in scientific notation. So if you do have the TI-84, you have to just remember how to change it from scientific notation to standard notation. Because if you look at the end of p, it says e to the -5. E to the -5 means you get the decimal place and you move it 5 places over to the left-hand side. So that means it should be 0.00003. But that's it for that one. Any question? Let me see, question. Yeah, so for ClassCal, you have to switch it over to data. Because if you don't switch it over to data, it's not going to let you enter the data set. So do make sure that you switch it over to data. Right. Any question on the TI-84? All right. So let me go ahead and let's transfer back to my notes. All right. So if you look at test statistic we got is -4.59. If you look at what we got for p-value is equal to 0.00004. So that's our test statistic and that's our p-value. Using our p-value, we're now going to make a conclusion because we want to compare our p-value to alpha. What do we say alpha was equal to? Yeah, 0.05. So which one's bigger, p-value or alpha? Perfect, alpha. So since alpha is bigger than p-value, what type of conclusion should I make? Should I reject the null hypothesis or should I fail to reject the null hypothesis? Sweet. So we reject HO. All right. So up next, we're gonna state the conclusion or state a conclusion. So to state the conclusion, what we have to just do, we have to just say, is there enough evidence or is there not enough evidence? So I want to say there. So we'll say there is enough evidence to support the alternative hypothesis that the mean height of, let's see, oh what? of the sunflower seed is lower than 15.7 centimeter when treated with All right. So for this one, we'll say there is enough evidence to support the alternative hypothesis that the mean height of sunflower seedling is lower than 15.7 when treated with extract from vinca minor root. And that's it for the conclusion. Any question in regard to the conclusion? All right. So what I want you to do, I want you to practice on this next problem. So I want you to come up with the null hypothesis, the null alternative hypothesis. I want you to come up with the test statistic. I want you to come up with the p-value. Tell me whether you should reject or fail to reject with that p-value. And then lastly, I want you to make a conclusion. So do this problem right now. So you practice on this one. If you get stuck, what happened?
On any upcoming test, are you gonna have us state conclusions too?
Probably not. I'll probably just have a like multiple choice conclusion where you could choose conclusion number 1, conclusion number 2, and then one of those will be correct.
Okay.
All right, guys. So take a minute and work on this problem. If you get stuck, you put something on the chat, and I'll try to help you out. Yeah, good. Sample mean is 11.92. Perfect. All right, so let me give you a little bit more time in case you need it. Yeah, alpha is 0.05. S is 0.26. Good. Oh, yeah, sorry. Alpha should be 0.05. Sorry, 0.01. Thank you, Rihanna. All right, so let's check out what do we have. Yeah, mu should be 12. Good. All right, so let's go ahead and do this problem. So mu should be 12. All right, give me a minute. For some reason, it stopped sharing, so I go stop share. All right, so mu should have been 12, n should have been 30. You should have gotten 11.92. That's your sample mean. And we also should have gotten S. S is equal to 0.26. And then alpha is 0.01. All right, everybody good with this so far?
Yep.
All right, so let's go ahead and do the null alternative hypothesis. So for the null hypothesis, we're gonna say mu is equal to 12. Because it's saying if the machine worked perfectly fine, it should always be giving out 12 fluid ounces. So we're going to just assume that 12 fluid ounces is our population mean. So our alternate hypothesis will be mu and 12. So the thing is, for this one, if you kind of read the problem, the setup of the problem, if the machine gives too much, fluid ounces of soda, that's bad. If it give if it get a little bit or less than 12 ounces, that's also bad. So in this one, if you look at it, it says differ from 12 ounces. So you want to put not equal to. And that's all you had to do for the null and alternate hypothesis. Any question in regard to the null or the alternate hypothesis? All right, so let's go to the test statistic. So if you look at this one, for this one, you want to do the t-test. Because if you do a t-test, it's because you only have sample standard deviation, which we only have S is equal to 0.26. We don't know the population standard deviation, so this one you're going to do a t-test. So when you did the t-test, what did we get for the t value? All right, thanks. So you get t is equal to negative 1.68. And that's your test statistic. Good. What did we get for our p-value? Yeah, good. 0.03. Oh, sorry, 0.103. So p-value is equal to 0.103. So then we have our alpha. Alpha we said was 0.01. So for this one, which one's bigger, p-value or alpha? All right, so you're using that symbol. So we're saying p-value is bigger. When p-value is bigger, what should I conclude? Should I reject the null hypothesis or should I fail to reject the null hypothesis? Good, we're on a row. Perfect. Fail to reject HO. All right. Everybody good so far with everything I have on the screen? Okay. So for this one, we're not gonna do a conclusion. We're just gonna ask, well, we're just gonna answer the question that they were asking. So if you look at the last sentence, it says, should Susan recalibrate the machinery? So for this one, should Susan recalibrate the machinery or is the machine working perfectly fine? Yeah. So for this one, the machine working perfectly fine. So our conclusion will say Susan should not recalibrate the machinery. And that's it. So Susan should not recalibrate the machinery because the machine is working perfectly fine. Because if we would have rejected the null hypothesis, that's when we were to state there's significant difference. But since we didn't reject the null hypothesis, since we failed to reject the null hypothesis, it's telling us there's not that major difference between 12 fluid ounces and what we got from the sample mean. And that's it. Any question in regards to this last problem? All right, so let's go on down. All right. So the next thing is we're going to go over something called distinguish between statistical significance and practical significance. So when we talk about statistical significance just means that we do pretty much our hypothesis test. And based off of the hypothesis test, is tell us that we should reject the null hypothesis. So that's what statistical significance signifies. What practical significance means that we actually look at the data set and the difference that it had is not that significant of a difference. So what we want to do, we want to be able to distinguish between statistical significance, where we do the whole process, and based off of that process, is tell us that we should reject the null hypothesis. But practical significance mean, is the sample mean and the population mean, is that actually a significant difference? So that's what we're going to tackle right now. So let's go ahead and do this next problem. So for this next problem, it said in 2003, the average age of a mother at the time her first childbirth, was 25.2. To determine if the average age has increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age 25.5 with a standard deviation of 4.8. Determine whether the mean age has increased using a significant level alpha equal 0.05. So first thing we're going to go ahead and do, we're going to go ahead and just label everything. So if you look at mu they tell us is 25.2. So this is our mu. If you look at our sample size is equal to 1,200. Up next, we have 25.5, which is our sample mean. So that's X bar is equal to 25.5. And then we get S, which is equal to 4.8. And we get alpha, which is 0.05. Any question in regard to any of those labeling so far? Okay, so the first thing we want to go ahead and do, we're going to go ahead and first just come up with the null and alternate hypothesis. So for the null hypothesis, we already have the null hypothesis. The null hypothesis is our mu. So we'll say null hypothesis is mu is equal to 25.2. My alternate hypothesis, we're trying to prove that mu is greater than 25.2. Everybody good for the null and alternate hypothesis? Okay, so what we're gonna go ahead and do, we're gonna go ahead and do our test statistics. So if you look at this one, since we have a sample standard deviation, we're gonna do a t-test. So let's go ahead and do the t-test. I'm gonna go ahead and use ClassCalc to be able to do this t-test. So on ClassCalc, you're gonna hit the stats button, you're gonna hit test, and we're gonna do a t-test. So if you look at mu was equal to 25.2. If you look at sample mean is 25.5. If you look at S of X is equal to 4.8. And then we get N is equal to 1200. So if you look at it, what do I get for T?
$2.165.
Yeah, good. 2.16. Well, we could just say 6 instead. Well, we could say 7 instead of 6.
Okay.
So we could say 2.17. And for this one, what's my p-value? Well, if you look at p-value, we chose the greater than. So greater than is 0.015. So let's say 0.015. Everybody go for the test statistic and the p-value. All right, so let's switch on over to this. So if you look right there, I got my t-test, which is 2.17. I got my p-value, which is 0.015. And then you have alpha. Alpha is equal to 0.05. So which one's bigger, alpha or p-value? So alpha, which is 0.05, or p-value, which is 0.015.
Is it alpha?
Yeah, alpha. So alpha is actually bigger than p-value. So if alpha is bigger than p-value, we should say reject HO. So if I reject HO, I'm saying, well, I'm rejecting the null hypothesis, and we're concluding that the mean age at which a female first gives birth has increased from 25.2. So this is what we call statistical significance. So pretty much we're saying this has statistical significance where there is a difference based off of the statistic. All right. But let's look at the practical significance. So if you look at this problem, it's saying it went from 25.2 and it increased to 25.5. Like, would anybody care if you told them it increased from 25.2 to 25.5? Like, probably not.
No.
Because this one, like, even though it has statistical significance, in practicality, it's not giving us that much. It's not telling you it increased by so much. Like, the only reason we're seeing statistical significance is because you had such a high sample size. So since we had a sample size of 1,200, that's why you're seeing it has statistical significance. But if we actually look practically, well, at the practical implication of it, it's not that much of a jump, because from 25.2 to 25.5, it's not that big of a jump. If it would have jumped from like 25.5 maybe to like 27 or 28 or something like that, that might be a little bit more interesting. But if it jumped from 25.2 to 25.5, it doesn't really Like we really wouldn't care. And that's what we mean by statistical significant and practical significant. Any question in regard to any of those?
Wait, so if if n was like, let's say 30, then it wouldn't be statistical significance?
Yeah, because let's say we go back to class count and I change it from 1200 to 30. If you look at the p-value now, you get 0.367. So that kind of show you how, like, yeah, if you do have a big sample size might mislead you to the wrong conclusion. Because if you look at it, if you just look at the pure number, there's not that much of a difference between the two of them. All right. Any other question, guys? All right, so let me go back to the notes. And I think up next should be hypothesis testing for a sample, well, for a population standard deviation. There we go. All right, so hypothesis testing for a population standard deviation. So let me just tell you up front, for this one, there's no function on the calculator that will do this for you. So for this one, you have to just know how to do it by hand. So I'll show you how to do it by hand. So first thing you want to notice that we're using the chi-square table or the chi-square value again. So if you look at it, in order to find chi-square, this is my test statistic. So this is your test statistic. So if you look at it, all you have to do is n minus 1 times sample standard deviation to the second power divided by divided by sigma square. And just know S square is just equal to sample variance. Sigma square is equal to sample variance or population variance. Right. Any question in regard to that formula? So for this one, we are going to be using this formula and we are going to be working this out by hand. Right. So this one, we kind of already went over it when we went over this. So those are going to be the 3 different formulas that we could use. So if you look at it on the left-hand side, sigma. On the right-hand side, that's where you're going to put the number. So whatever we think our standard deviation of the population is, we're going to put standard deviation equal to that number. And then if you look at our alternate hypothesis, the alternate hypothesis is showing the 3 different alternate hypotheses we could have, which is not equal to, less than, or greater than. Any question in regard to the null and alternate hypothesis? All right, so let's move on down. Okay. So let's go ahead and do this problem. So for this one, said a can of 7-Up state that the content of the can are 355 milliliter. A quality control engineer is worried that the filling machine is miscalibrated. In other words, she wants to make sure that the machine is not under or overfilling the cans. She randomly selects 9 cans of 7-Up and measures the content. She obtained the following data: 351, 360, so on and so forth. So it says, assume the population standard deviation was 3.2. Test the claim that the population standard deviation sigma is greater than 3.2 milliliter at the alpha 0.05 level of significance. All right, so if you look at this problem, they give us population standard deviation to be 3.2. They give us alpha to be 0.05. For this one, what's my n?
Is it 9?
Yeah, good. So the only thing is missing is my S value. So the way I'm going to get my S value is from this, where you get our sample standard deviation from this. All right. Any questions so far on this? All right. So before I go ahead and find S, we're going to state the null and alternate hypothesis. So the null hypothesis is that sigma is equal to 3.2. My alternate hypothesis is sigma 3.2. Which sign should I put between sigma and 3.2?
Greater?
Yeah, greater. So we want to show that it's greater than because this is greater than. All right. Everybody good for my null, my alternate hypothesis? All right. Up next, we're gonna go ahead and get the S value. So we're gonna use class calc in order to get the S value. So let me share class calc. Where are you? There you go. So erase. All right. So if you look at class calc, you go to stats, and you go right here where it says standard dev. So enter that, and all you have to do is enter the number. So you go 351. You go 360, you go 358, you go 356, you go 359, you go 358, you go 355, 361, and that's the 352. All right. So if you look at it, they gave me two standard deviation, they gave me sigma, and they gave me S. Since the 9 is a sample, we want to use S because sigma would be that this is the entire population. But that's not true. It's not the entire population. It's a sample of 9. So you want to say S is equal to 3.464. Any question? I got 3.464 for S. All right, so let me go switch over to my notes and we can work it out. All right, so if you remember for the test statistic, the formula for test statistic is n minus 1 s squared divided by sigma squared. So for this one, n, it's 9. So you go 9 minus 1. S is 3.464 squared. Sigma is 3.2. And you do square. Any question on any of the substitution into that formula? All right, so what I'm going to go ahead and do, I'm gonna go ahead and work this out. So I'm gonna do 9 minus 1, which is 8, multiplied by 3.464, put that to the second power, and then divide it by 3.2 to the second power. If you do that, you should get 9.37445. Everybody good on how I got chi-square? All right. So this is my test statistic. Now what I'm going to go ahead and do, I'm going to go ahead and find my p-value. So to do the p-value, I find it helpful if I draw it out. Please remember, since this is a chi-square distribution, it's skewed to the right. So I'm going to draw something that's skewed to the right. So in case you forgot, for the chi-square distribution, it always starts off at 0. So it doesn't have a negative infinity. And then you have 9.375445. I'm going to say that's over here. So which side should I shade? The left of 9.3 or the right of 9.3 if my alternative hypothesis says greater than? Yeah, good. The right. So for this one, if you look at it, this will be my lower bound. So my lower bound will be 9.37445. My upper bound, if you look at it, since you keep going and going, your upper bound will be infinity. Any question on lower bound and infinity? Also for this one, you are gonna need degrees of freedom. What's my degrees of freedom in this problem? Let's see if you remember. Yeah, good, thank you, 8. All right, so lower bound is 9.37445. Upper bound is infinity. Degrees of freedom is 8. So I'm going to switch over to class calc, and then I'll show you how to deal with the TI-84. So we'll do class calc. All right. So in class calc, what you want to do, you want to go right here with this stats, and this time you want to hit distribution. And what you want to do, you want to do a chi-square distribution. So for the chi-square distribution, if you look at it, it says DOF. DOF just stand for degrees of freedom. So I put degrees of freedom of 8. Then what you want to do, you want to do CDF. And then what you want to do, you want to do the lower bound. If you look at it, class calc already said lower bound 0. So in case you do forget 0, class calc will remind you. And you put 9.3, oops, 37445. And then upper bound is infinity. So if you look at the p-value I get, you get p-value of 0.3117. So you get p-value of 0.3117. Everybody was able to get p-value of 0.3117. All right. So that's how you do a class calc. And if you want, you could actually go ahead and finish out the problem. You could say if you should fail or reject the null hypothesis, so on. Because right now I'm going to show the people that have a TI-84 how to do it. All right. So if you have a TI-84, what you want to do, you want to hit the second button. And you want to hit VARS or bars. And if you look at number 7, you want to go one below number 7. Oh, sorry. Yeah, one below number 7 to number 8. And it says chi-square CDF. If you put chi-square CDF, it asks you for the lower bound. Lower bound is 9 point, oops. No, I don't want to do that. It's 9.37445. My upper bound, remember in the TI-84, it doesn't have infinity. So you do 10. So you do 10 to the 10 power. And then degree of freedom is also 8. You go ahead and paste. You enter, and you get exactly the same thing that we got using the using class calc. Right. Any questions for the TI-84? Perfect. All right, so let me go ahead and switch over back to the problem. So if you look at it, we got p-value, which is 0.3117. We got alpha, which is 0.05. Which one's bigger, alpha or p-value? Yeah, p-value, perfect. So since p-value bigger than alpha, we should fail to reject HO. Any question why we failed to reject HO? All right, so last thing what we want to go ahead and do, we're going to go ahead and do a conclusion. All right, so for this one, since we failed to reject, we'll put there is not enough evidence to support the alternate hypothesis. That the standard deviation for, what was this again? I think it's milliliter. So we state there isn't, there is not enough evidence to support the alternate hypothesis that the standard deviation for 7-Up content is less than 3.2 milliliter. And let's say you do that first problem for testing the population standard deviation. Any question in regard to that first problem?
For class calc, you went to stats,
Distribution.
distribution, and then what did you push after that?
Yeah, I'll show you right now. So you go to stats, you go to distribution, and you go right here where it says chi-square. So it has the x squared distribution.
Okay, perfect. Thank you.
Also, if you want, if you kind of remember how to spell it, you could just put chi-square distribution. And then you can put degree of freedom of 4. And then you can go ahead and do it.
Okay.
So let's go back to the notes. Oops. This is not the notes. These are my people. All right, so right now we're going to skip this stock investment risk and we're going to this one. So we're going to do the one that says a manufacturer of candy must monitor the temperature at which the candy are baked. Too much variation will cause inconsistency in the taste of the candy. Past records show that the standard deviation of the temperature has been 1.2 degrees Fahrenheit. A random sample of 30 batches of candy is selected and the sample standard deviation of the temperature is 2.1 degrees Fahrenheit. at the alpha, or at the 0.05 level of significance, is there evidence that the population standard deviation has increased above 1.2 degrees of Fahrenheit? Alrighty then. So let's go ahead and just label everything out. So for this one, what do they tell us is our sample size? Good, 30, perfect. Perfecto. So all we need is S and sigma. So of the 30, what was the standard deviation of those 30 batches? So just remember, just look at where you found 30, and in the same line, you should also find that. So good, so it's 2.1. All right, so in order to keep the consistency of the candy, it said that the standard deviation shouldn't be higher than what value? 1.2, good. So for the null hypothesis, we're going to state the null hypothesis standard deviation is equal to 1.2. So that's saying that yes, the temperature or the variation of the temperature is 1.2 degrees of not degrees of freedom, degrees Fahrenheit. So that's the null hypothesis, but they're not trying to prove that the standard deviation of the temperature is 1.2. They're trying to prove that the standard deviation of the temperature is what? Is it less than 1.2, greater than 1.2, or just different than 1.2? Yeah, greater. All right, so that's my null, that's my alternative hypothesis. Any question for my null and my alternative hypothesis? Okay, so let's go on to test statistic. Test statistic is chi-square is equal to n, which is 30, subtracted by 1 times s, which is 2.1 square, all divided by sigma square. So I'm going to go ahead and just calculate that out. So if you calculate all of that out, you get 88.8125. I'm pretty sure you can just cut it off to 88.8 and you'll still get the same precision that we get. All right, but any question for that test statistic? All right, so we're gonna do p-value. So for p-value, once again, we're gonna draw this because this is gonna help me figure out what's my lower bound, what's my upper bound. So remember, the lowest it could be is 0. I'll say 88.8125 is here. So which side should I shade? Should I shade the left-hand side of 88 or the right-hand side of 88? So left side or right side?
Right.
Yeah, good. Thank you. So we'll say right. So that means my lower bound will be 88.8125. My upper bound will be infinity, so 10 to the 10 power or infinity. Any questions so far on the labeling? All right. Lastly, one thing I forgot to get, what's my degrees of freedom?
29.
Yeah, good. All right, so I'm gonna go ahead and do this in ClassCalc. I'll also do this in the TI-84. So that way you can see me work it out for both of them. All right, so in ClassCalc, you wanna go to stats, you wanna go distribution, and we go to chi-square distribution. So if you look at it, it asks for degrees of freedom, which is 29. You do CDF, and you do lower bound is 88.8125. 0.25, and then you do infinity. Ooh, cool. So if you look at Class Calc, it actually gave us scientific notation. So it's 6 times 10 to the negative 8. So that means I'm going to move the decimal 8 places to the left. So that means my p-value is 0.000456. Well, it's pretty much pretty low. And you should have see that coming, because if you saw that our chi-square value was 88.8, it kind of telling you there's a big difference between the two. All right. Any question in regard to Class Calc and how I got this? All right, so let me do the TI-84. TI-84, you go to second, you go to bars, you go to number 8, which is chi-square CDF. You once again put 88.8125. Leave everything alone except for the degree of freedom. You put degree of freedom at 29. We go over here, paste. We'll paste it. And it gives you the same thing of 5.5 e to the negative 8. If you look at the 5.5, actually you can use the 5 to round up that other 5 to 6. All right, but Class Calc and the TI-84 gave you practically the same answer. Any question for TI-84? All right, so let's move over to the notes. So which one is bigger, p-value or alpha? This one should be really, really simple. So p-value or alpha? Yeah, good, alpha. So alpha is bigger, so that means we reject HO. So we reject the null hypothesis. So that means we don't believe the standard deviation of this room is 1.2. We actually think the standard deviation of this room is higher than 1.2. So let's go ahead and do a conclusion, and that's it. So we'll say there is enough evidence to support the alternate hypothesis that the standard deviation temperature is greater than 1.2 degrees Fahrenheit. And that's it for that second problem for standard deviation. Any question for that second problem of standard deviation? All right, so let's do. All right. So what I want you to do, I want you to practice on this next problem. So try to go over everything. So I'll give you roughly like 4 to 5 minutes to do it. And if you have any question about like what is N, what is S, or what's the population standard deviation, ask away. So try to work this out. So I'll give you 5 minutes to do it, and then I'll go over the whole problem. But do try to practice on it, for that way you can see if you understand how to do these type of problems. So go ahead and try to do this one. All right, so let's try doing this one. So for this one, what's my sample size?
25.
25, cool. So we get 25 because they say sample 25 doorknob. They go n is equal to 25. So they tell us s is equal to 0.025. They tell us sigma is 0.035. And lastly, alpha is equal to 0.05. All right, let me see. Let me stop sharing because apparently it stopped share. So let me just reconnect it again. All right, so if you look at it, n is equal to 25, s is equal to 0.025, sigma is equal to 0.035, and alpha is equal to 0.05. All right, any question in regard to any of that? Okay, so if you look at the null hypothesis, they tell us standard deviation will equal to 0.035. My alternate hypothesis will be sigma and 0.035. But in this case, like they say, they want to reduce. Let me see, where does it say reduce? So it said they want to reduce the variation. So variation, the other way of saying standard deviation. So since they want to reduce the variation, that means we want it to be smaller than this. So that's your null, and that's your alternate hypothesis. Cool, thanks. All right. Any question in regard to that so far? So let's go ahead and calculate chi-square. So chi-square is equal to n, which is 25 minus 1 times s squared, which is 0.025 squared, all divided by standard deviation of 0.035 squared. So let's see, what do we get? So we go, so hopefully everybody got 12.24. Was everybody able to get 12.24? Perfect. All right. So up next, we're gonna go ahead and do this calculation. So remember, the lower bound is 0. So for this one, we'll say 12.24. And if you look at the alternate hypothesis, it says less than. So you shade the left-hand side. So in this one, the lower bound will be 0. My upper bound will be 12.24. Any question in regard to my lower bound, my upper bound? All right. And also, in case you forgot, you also have to calculate degrees of freedom. Degrees of freedom will be equal to 24. So now I'm going to go ahead and just plot this out. So you can either do it in class calc or you could do this on the TI-84. So you do lower bound is 0, upper bound is 12.24, and then degrees of freedom is equal to 24. So if you do this, you get a p-value of 0.0229. And then you get an alpha. Alpha is equal to 0.05. Everybody good for p-value and for alpha? All right, so which one's bigger, alpha or p-value? You got alpha. So since alpha is bigger than p-value, that means we reject HO. So that means we reject the fact that the standard deviation of these doorknob is 0.035, and we're concluding that it actually was reduced, and we're going to say that the standard deviation is now lower than 0.035. So let's go ahead and put that. So we'll say there is enough evidence to support the alternative hypothesis that the standard deviation for doorknobs is lower than 0.035. 0.035. All right. And that's it for that problem. Any question in regard to that last problem? All right. So if you look at it, there's a couple of more problems to do, but I'm going to leave that just for practice. So we're all done for chapter 8. So we're all done for chapter 8. So that means on Monday you're going to have a quiz on this chapter. So you kind of review the hypothesis test. So for this one, you're probably going to get one question and you have to do the hypothesis test for it. So you have to do like find the null alternate hypothesis, find the test statistic, find the p-value, reject it or fail to reject, or make a conclusion. So that's what your quiz is going to be on Monday. It's going to be a hypothesis test, and you have to do all 4 parts for the hypothesis test. Any question in regard to that? No, for this one, I think the quiz, you're going to have one question. And the one question, you're going to be pretty much just to do the whole, to do all the parts for the hypothesis testing. So it could be do the null, do the alternate hypothesis, find the test statistic. Once you find the test statistic, find the p-value. Once you find the p-value, say if you should reject or fail to reject, and then you make a conclusion. Well, pretty much. Well, it could be from eight. Let me see what chapter. So for the quiz, it could be anywhere from 8.3 all the way to 8.4. Yeah, I could work out the thing, the last two ones for that way you could practice on it. So there's one thing it says reduce the variation, but at the end it said, is there enough evidence that the new process is more effective? So this kind of going back to the definition of standard deviation. Standard deviation, the smaller the standard deviation is, that means the more consistent it is or the more effective it is. The bigger your standard deviation get, the less effective it is. So when they say more effective, they're technically speaking that the standard deviation should get smaller. So that way the standard deviation should be lower, not greater than. Any other question? Yeah, you're welcome. All right, so I'm gonna end the meeting. I'll upload the notes. So for the notes, I'll upload them like in a day or two. For that way, I could solve those questions, and for that way, you can have the answer for those. Once again, for the quiz, it could be 8.3 to 8.4. So anything from 8.3 all the way to 8.4 could be on the quiz. So I'm gonna upload the notes probably in a couple of days, and I'll upload the video in case you had to leave early or if you showed up late for the quiz. All right. Any questions before I shut down the meeting? All right.